Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about circular cube. It is one of the type of the cube. In the previous lectures, we have discussed about what is cube, what are the operations on cube, how we are perform the operations using C program. We implemented the cube also. In array representation also we are discussed. We have two pointer, front and rear pointer. Front pointer is pointing for front location. Rear pointer will insert the element. When we want to delete the element, we will delete from the front pointer. So whenever we are inserting, that we are saying that NQ operation. Whenever we are deleting, that is the DQ operation in the cube. The same we will perform in the circular cube, but only small modification is there in the insert and delete the element. While doing insert and delete the element into the cube, how we are performing the operation. So that is we are going to discuss in this video lecture. So dear students, this is week 7, lecture 1, classroom discussion topic 19. We are going to discuss this video lecture. The topic is circular cube. So before going to discuss about the topic, we must be discuss about the lecture outcome of this particular lecture hour. After completion of this lecture, the students will be able to develop a C program to demonstrate the circular cube data structure with its operation using array. Using array, we are performing the operations of circular cube. So initially we know that cube means it is the using array we are represent. So here we are using two pointers. Front pointer is pointing to first location and rear pointer is used to insert the element. Here as per this diagram, all the elements are inserted. So rear pointer is pointing to last location. So whenever we are declaring the array, so we know that array name and within the square bracket we will mention the size of the array. So if we have defined hash define max is 100, if you are declared, you can fix the size for max, q max you can write it. So now we are declared the integer array with array name is q, then maximum value you can give. So 10 it will take. Okay. So after taking this value, it will start. So array memory will be created. So like when we are using the array indexes start from 0 to 9. Okay, 0 to 9 means max minus 1. So here we are declared maximum is 10. So array indexes start from 0. So hence we can write the max minus 1. Okay. So whenever we are inserting element, we can write, we have to check the queue is empty or not. First, whenever we are doing the NQ operation, NQ means insert operation. NQ operation, what are the conditions we are going to check? First one, queue is empty or not. Okay, if empty means what we have to do. Okay, and queue is full or not, we have to check. Okay, so if it is full, what we will do? So when we are inserting it is full means we are unable to insert any other element. That's why we simply print the queue is full or it is overflow. Okay, we can just print overflow. Otherwise, if it is empty means initially we can declare two pointers, front pointer and rear pointer. Whenever we are declare the pointer, we initialize the value with -1. -1 means it is the nil value. Okay, it is not pointing anything. -1 represent nil value. So both are integer type of the variable. The variable is pointing to the location. Okay. So whenever we are saying the pointer means this is a location. So initially it is -1 means the queue is empty. If empty means what we have to do? Both the pointer will pointing to the first location when we are insert the first element. So for that reason we have to change front equal to rear equal to 0. So that means now both the front pointer and rear pointer is pointing to the first location because queue is previously empty. If empty means we have to insert the first element here, and here front pointer rear pointer is pointing to the same location. Okay, so if this we are changed to 0, then automatically q of rear equal to whatever value you have to insert, that you can keep it here. Okay, this is the concept you have to use for insert operation. Okay, delete operation means normally we have to check it is delete. If in case empty queue means we are unable to delete element. Okay, so initial, if empty means what we have to check, if friend and rear friend equal to rear equal to -1. So this condition if we are checked, this condition true means it is empty queue. Okay, so we are unable to delete the any element from the queue. So simply we can write underflow. We will print that underflow or queue is empty. That we will write it. If this condition not true means we are able to delete. No, so friend pointer we can use friend plus plus. Then it is the meaning of delete operation. Okay. So what is this? Why we are going for circular queue? So this is the linear queue. Just to see here. Okay. So in this example, what is the meaning? First two, there is no element, but all the elements are filled. That means here friend pointer is pointing to this location, second location. Second means array of second. So that rear pointer is pointing to this location. So what is the meaning? Actually, if it is a linear queue means we are deleted the two element, here no elements are there. So when we are inserting the element, we are checking, so the rear equal to max minus 1 means we are simply saying that q is full. Okay, but you see here this is a linear array, we are deleted two elements, even two space is there, even we have the two spaces also, we are unable to insert the element. That is the drawback of linear array or linear queue. So for that reason, what we are going to do, this if two spaces is there, no, if two spaces we can insert the new element. For that reason, we will go for circular queue. This is just symbolic diagrammatic representation of the circular queue. So this is the first location, q of 0. So plus 1, next element, next location, like that. The last location will be connected to the first location. Okay. So initially what we will do, if there is no elements are deleted means friend equal to 0 only. When we are inserting first element itself, we are fixing this value 0. Okay. So when the circular queue is full, friend is not deleted any value and rear is reached max minus 1. So both the condition true. Okay. Both the condition true. Then only the queue is full. Okay. So previously linear queue we are checking this condition only. Now we are checking this condition also, because in front position some space is there or not we are checking. Okay. So in case it is not equal to 0, if front pointer is not equal to 0 means, what is the meaning? Rear is pointing to last location, maybe full, max minus 1. So if it is equal to max minus 1, then rear we are changing to 0th position. If front not equal to 0 means we can insert element into the 0th location. Then rear plus plus we can write one by one up to where the front pointer is pointing. Okay. So this is the circular queue concept we are using. So see this diagram. First one, queue is full. When it is full, front equal to 0, rear equal to max minus 1. This both the conditions are true. Both the conditions are true, queue is full. Otherwise, it is not full. If rear is reached to max minus 1, okay, it is not equal to max minus 1. So what happened? In last some places is there, simply we can insert the element here. So for this, simply we can write rear plus plus. Okay, rear plus plus or rear equal to rear plus 1 we can write and we can insert the element. Both the condition is not there. Both the condition is not there. So what we have to check? Rear is reached to max minus 1 and front is not equal to 0. This is the circular queue special concept. So if this condition is there, simply we can change rear equal to 0 and insert that element into rear position. So here we are initializing rear equal to 0 now. So rear pointer will comes here and this pointer if we are fixing here means we can insert the element here. After fixing rear equal to 0, q of rear equal to the value, whatever value you want to assign, you can assign it. It will be insert. Okay. So this is a concept. When we are inserting the element, we have to remember this algorithm. First, we have to check it is full or not. Full means friend equal to 0, rear equal to max minus 1. If it is condition true, simply we can print overflow. Okay. Then go to step 4, exit. Just come out. We are not able to perform insert operation. If not, this condition is fails. Then we have to check both are empty queue or not. If empty means we can insert the first element now. So we have to set the front and rear equal to 0. After fixing it, we can insert the value in the rear position. If this condition also not there, queue is not full, queue is not full, queue is not empty. Okay, so both the conditions are true. That means again it will check. So rear it may be we have to it is pointing to max minus 1 or not. If max minus 1 it is pointing, then we have to check front not equal to 0. For why? Because we have to insert the element into first position, rear equal to 0. Okay. If all the position we are fixing the rear pointer. After fixing the rear pointer, so this condition it is not full, it is not empty. So we are fixed first location is free. So somewhere we are fixed no, there we have to insert the element. That's why we are using rear equal to rear plus 1. Some this all possibility is not there means already space is there for insert as per rear side. Okay. So once we fix the rear side, then we can insert the value into Q of rear. So there simply we are assigning the value. How we can delete the element? So again, I already told no. So front and rear equal to minus 1. Initially we have to initialize the value minus 1 for front and rear pointer. When it is equal, same means there is no element. If there is no element means we are unable to perform the delete operation. Simply we can print under flow. Okay. But see here in this diagram, second diagram. In this diagram, one element is there. Okay. So front and rear, front pointer is pointing and rear pointer is pointing the same location. When it is same, it is not minus 1. When it is same, so what is the meaning? Both are in the pointing to the last element. If the only one element is there, that is also in the last position. So when we are removing this element, we have to set it into minus 1 because there is no element in the queue. So the queue is empty. After removing this, queue is empty. So we can fix minus 1 for both the pointer. Okay. So you see here, once queue is full, so front pointer queue is full, then when it is full means the last elements are inserted one by one, one by one, one by one, entirely full. Then we are deleting the element one by one, one by one, one by one. So we are waiting for the last position front pointer. Okay. First time it is inserted all the element. We are deleted all the element without last element. So last element is there. So it is circular queue now. Again rear pointer starting from the 0. It is inserted already 6 elements in the queue. Okay. So the rear is circular queue. It is not initial value. One time all the elements are inserted. Then second time it is started from 0 up to 5 it is reached. So 6 elements are inserted. After first all the elements are deleted. So now front pointer is here. Rear pointer is here. In this condition, where we have to insert, we are insert here. Okay, so what condition we have to check? Front is greater than rear. Okay, front value is greater than rear means rear plus plus we can write. Then we can delete it. Okay. So same condition, front equal to minus 1 means no element deleted. So there is no space, under flow we can write. And then simply what value we are removed that we have to print now. That's why Q of front value we are returning it. So otherwise front and the rear both are equal or not we have to check. If it is equal, simply we can assign minus 1 for the both the values. Because if we are finding both the position are empty queue, we are unable to delete the element. In case if it is front equal to max minus 1, front pointer max minus 1 means the next element you have to delete in the first location. So again you will start from 0. Okay, if all the condition fails, then if the element is deleted in the linear queue order only, front equal to front plus 1. So same method we have to follow for delete operation. So these are the program for inserting the implementing the circular queue. So insert operation, delete operation. So if you are given the choice, it will take the option According to option, it will work. Option 1, insert operation. Option 2, delete operation. Option 3, pick operation. Option 4, display operation. If you are given 5 or up to 5, it will ask again and again. This do while loop, no? So here is while loop. Here do while is there. Do is starting here. While is here. So this loop will be executed again and again up to not equal to 5. Okay. So if you are given 5, it will be over. So insert operation, what we are going to check, we will take one value for insert. We have to check both are friend equal to 0. That means it is pointing to first value, rear equal to pointing to last value. So entire queue is full. So if Q, this condition is Q is full. Q full means what we will print, overflow will print. So next, if it is not full means we have to check empty. Empty means both the pointers equal to -1. So now Q is empty, we are checking. So if it is true means simply we can change it to first location. First value we are inserting. That's why we are changing to 0. After 0, simply we can assign the values, whatever value we are getting here, that value assigned to rear position. Okay. So if in case rear is reached to last position, front is not equal to 0, means in the front side the spaces are there. So the rear pointer will change it to 0. It is pointing to the first location. Then there we have to insert the element. So this element will be incremented up to 1. So if the condition again and again, we will do this for insert the next element. Okay. So finally that last element will be assigned here. It will be printed. Okay. So next, delete element. Delete element, we have to check Q is empty or not. Empty means we are unable to delete. Simply we can print underflow. Okay. So we have to return -1. -1 means nil value. So which element we are deleted, that value will be assigned to value for printing purpose. This element is deleted. We want to print. If in case both are pointing to the same location, what we have to do? Only one element is there in the queue. So that queue, after deleting it, automatically the both the pointer will pointing to -1. Okay, there is no element into the queue. If these conditions are failed, then we have to check friend equal to max -1. Okay, friend max -1 means only one element, that is also in the last position. The last position it is there means simply we can change the first position. Front pointer will be first pointer. Because rear is we are not checking. Rear may be some values. Okay, some values are there. So in that condition we are changing to 0. Otherwise we can use that friend plus plus for finding the next location. After changing everything, return whatever value we are getting, that deleted, that value will be passed to the called function. So now pick operation just return the where the friend pointer is pointing to the location of Q. Okay. So first, if some element is there, then only we are able to perform this pick operation. That's why Q, some elements are there or not, we have to check. If it is not there, simply we can print Q is empty. Otherwise, we will return this value. Display, we know that. So first, if front pointer is the location pointing to first location, okay. So that rear pointer pointing here. Whenever we want to print front to rear, we have to print. Okay. So for that, this loop they are using front to rear, they are printing. Okay. But in circular queue, what happens? Sometimes front pointer from the front pointer will check. Okay. But the rear pointer is maybe first side. So starting side. So up to maximum point we have to check. Okay. So example Q is there. Okay. So here, in case front pointer is pointing here, front pointer is pointing here, rear pointer is pointing here. We are not able to print front to rear, this position. We have to print up to this position, then starting from the first position to up to rear position. So what we have to do? So front, starting from front up to max -1. Okay, after reaching max -1, here again it will start from 0. So starting from 0 to where the rear pointer is pointing. That is the second for loop. Two for loop we are using for printing the elements in order in the circular queue. Okay, this is a sample input output. After executing the program, we get this output. So now we are in the last slide. We are discussed about the circular queue. What is circular queue? Why it is needed? What is the disadvantage of linear queues? like example, even we have the space also, we are not able to insert the element. Especially for that purpose, we are coming for circular queue. What are the conditions we have to use for circular queue? We check it is full or not, it is empty or not, if the front pointer pointing to last location or not. Like that, we are checking the condition no that we are discussed. Next algorithm, both algorithm we are discussed, and finally with the program we are explained all the concepts of circular queue. Okay, so now it is the time for you. You have to write and show. Okay, show the following operation with the help of circular queue and draw the queue after each operation with the front and rear pointer. Okay, so first you can give the numbers 1, 2, 3 like that. So 1 NQ operation, NQ 12. So you can say that Q will be generated with the maximum size. So first values are 12. Can insert here. So number 2, what you have to do? Again NQ. So NQ 21. So next first value 12, then 21. Can show like that one by one. Okay. So now we are in end of this session. We have to revisit the lecture outcome. Having completed the discussion on circular queue, now students should be able to develop a C program to demonstrate the circular queue data structure with its operation using array. Okay. As well as students can apply the concept for real-time applications. So even if you have doubt, you can refer the topic in Rima Thareja textbook, types of queue under that 8.4.1 circular queue. Okay. So further doubt, if you have any further doubt, please come with the doubt. We will discuss in the classroom. Thank you very much for listening this video without interrupting. Thank you all.